Hello there, welcome back to STR8CHEM. In this video, we're going to learn about the Chatelier principle, and this principle states that if a stress is applied to a reaction that is already at equilibrium, the reaction will counteract the way to reduce the effects of the stress or to relieve the stress to gain a new state of equilibrium. There are three types of stress that you need to know for the Chatelier principle. The first one we're going to look at is on concentration, which is the easiest one. And then we're going to look at the effects of temperature. And then the third one, we're going to look at pressure. And usually when we talk about pressure, it will comes together with volume. So these are the three stress that we look at on the discussion about the Chatelier principle. Let's have a look at the effect of changing concentration in the reaction at equilibrium. So what's going to happen to the system at equilibrium if we're going to add or if we're going to take out some of the reactants or products? Is it going to be shifting to the left or to the right? To do that, let's consider this reaction over here. As you can see, we have a homogeneous chemical equilibrium. And if you look at the end here, you have the value for delta H or the enthalpy. For the effects of concentration, you don't have to worry about this number yet. So we can look at this number later on in the video when we want to consider about changing the temperature of a system at equilibrium. Okay, just now we have talked about that this system is homogeneous. Okay, so we're going to think about what will happen when you add H2 to the system. So when we add H2 on the system, H2 is one of the reactants. So when you add this up, so what's going to happen? The system will try to counteract to the effect of adding H2O so that it will achieve a new state of equilibrium. So you can visualize that in this form of diagram. So in the beginning, before you're going to introduce the stress, so this is the stress that we want to introduce. Okay, so that is the stress that you want to introduce to your chemical reactions at equilibrium. So after you have introduced the stress, what happened over here? You have this process in which in the middle, the chemical equilibrium tries to counteract the effects of the stress so that you will be able to achieve a new set of equilibrium. The one that you are looking at this bit over here, okay, so that is the green part over there is the new set of equilibrium. So when will that's going to be achieved? After you have introduced any form of stress. So in this case, we are adding the concentration of your H2. And as you can see in this graph over here, concentration versus time, the reactions at equilibrium, okay, will try to counteract to the adding of H2, and they want to achieve equilibrium. So the equilibrium will not going to be disappeared. Okay, equilibrium will not going to be eliminated, but you just going to be having a new state of equilibrium after you have added a form of stress. So when you add that one, the equilibrium will shift to where? So the equilibrium first, you're going to tell them that the equilibrium position, shift to which direction. When you add this one is going up, you're going to add that up. So how you're going to counteract that? You're going to go to the right. Okay, you're going to go to the product site. We'll shift to the in brackets producing more product. In this case, NH3. Okay? So when you shift, after you have shift to the right, what happened? Equilibrium, the new sets of new equilibrium is achieved. Okay? So when you add the concentration here, the position, equilibrium position will shift to the product side or to the right hand side so that you will achieve new sets of equilibrium. Okay, so what if we are going to have a different situation? Just now we have added H2. Now, what if we're going to add NH3? So you're going to add this one now. You're going to add NH3, so the concentration will go up. So when that one is going up, how does the reaction counteract with that application of stress? For sure, the chemical equilibrium will shift to the left. Okay, we'll shift to the left. Okay, so you're going to write equilibrium position shifts to the left in brackets to the reactant side. So the reactant is H2 and N2. After that, new sets of equilibrium is achieved. Okay, so it's quite easy. So let's have a go at another situation. What if I am gonna be taking, okay, I'm gonna be taking out, if I am going to reduce N2. So what happened if we're gonna reduce N2? So this concentration is reduced. So when that one is reduced, what happened? So you're not gonna shift to the right, but when this one is reduced, you're gonna shift to the left because you want to make more of N2 when you are reducing this. Okay, so the number one, the equilibrium shifts to the, remember, when you are reducing N2, you reduce this, it will shift to the left. To the reactant side. So you have H2 and N2. All right. It's quite easy, isn't it? So when you add concentration right over here, it will shift to the left. If you reduce the concentration of NH3, it will shift to the right. If you increase concentration of this, it will shift to the right. If you reduce the concentration of your reactant N2, it will shift to the left. Same goes to this. So if you increase the concentration of H2, since H2 is your reactant, the equilibrium system will shift to the right when you increase the concentration. If you reduce the concentration, the equilibrium system will shift to the left because you reduce the concentration of H2, which is your reactant in this reaction. So the equilibrium constant will try to counteract and it will shift to the sides with lesser number of H2. You want to make more of H2 so that the equilibrium will be achieved. Okay. So what about a homogeneous reaction over here? Okay, we have this heterogeneous, just now homogeneous, since you have liquid, and then you have aqueous over here. So this one is heterogeneous. So the concept is still going to be the same. So if you're going to add the concentration of your reactant aqueous over here, you will have a counteraction. So when you increase the concentration of C4H7O2, it will shift to the right. If you reduce the concentration of your aqueous reactant, it will shift to the left. If you increase the concentration of C2H4O2, if you increase the concentration of this aqueous product, it will shift to the left. If you reduce the concentration of your product, aqueous, any one of them or both of them, if you reduce them, so the equilibrium will shift the position to the right. But if you have this here, if you change this, changing pure liquid and pure solid concentration, what happened? Does not affect the equilibrium position. Okay, so we're going to apply the same type of concept that we have learned how to write equilibrium constant expression, in which pure liquid and pure solids will not going to be considered in the equilibrium process. Same goes to Le Chatelier's principle. If you change the concentration of your pure liquids, or if you change anything about the pure solids, so the equilibrium will stay the same. So there will be no shifting will occur. Okay, so no shifting will take place. So you're going to write over here, if you change this, pure liquid or pure solid, no